So decimals are used in the real world. The measuring earthquakes, that's a Richter scale, that's based on logarithms. Decibels, same thing, it's based on logarithms. And logarithms are in formulas and other things we use in business and medicine and things like that. So here we have a little bit of an example. The amount of energy released from one earthquake was 500 times greater than the amount of energy released from another. But then they give us the equation. The equation, 10 to the x equals 500. So we're going to use the equation they gave us. Represents this situation where x is the difference. Okay, so they tell us what x is. It's the difference in magnitudes on the Richter scale. Okay, so to the nearest thousandth, which that means 3 decimal places, what was the difference in magnitudes? So what they want to do is they want us to solve for x here. It says what was the difference in magnitudes. So we're trying to figure out x, okay? All right, it's in exponential form, but I'm going to change it to logarithm form. So I'm going to think log base 10, but I don't really have to write that 10, but I did, of 500, so you start with the base, go over here, pick up the argument, equals x. But this is a common log, it's base 10, so it's log of 500, oops, equals x. All right, so we get our calculator, and we're going to go log 500, and what is that? It's approximately 2.699. If I round off, it's going to round up, so 2.699. That's the difference in magnitudes. So if you had a 4.4 earthquake, and then another earthquake hit that was 500 times greater, that's going to measure like, 7.99 on the Richter scale. Do you see what I'm saying there? So sometimes people think, oh, it's a 4 earthquake and it's a 3 earthquake, on the Richter scale. But that really represents 10 times greater, okay? So anyway, that's a little bit of an explanation of the Richter scale and logarithms. But we just wanted to find the difference in magnitudes, and that was 2.699. So I made up the 4.4.